YouTube viewers, Sweet Tips here. Here is our cement silver out of that jeweler's waste, my previous video. If you look here, let's see if I can get the camera on it right here. That's our piece of copper. And all the silver's down at the bottom down there. I think this reaction is complete. And what I wanted to do here was find out exactly what we got in this solution. It's making it turn green like that. So what I've done is I've set up some tests over here for us to conduct on this solution. What I'm going to do is reach in. I've got two tubes here. I'm going to reach into our green solution over here with a pipette and draw up some of that solution, add it to each one of these tubes. Now what we're going to do is we're going to add some DMG. Here's my DMG down here. I use this for testing. Got a pipette labeled DMG. So I'm going to grab some of this DMG and add it to one of these tubes. If there's palladium in here, you should get a bright yellow precipitate coming out of solution. I don't see anything like that happening there. Upside down one time to mix it good. I'm going to set this in this little container here. And then to this tube, I've got some palladium standard testing solution. It's got a 1/10 of a gram dissolved in 100 ml of solution. Palladium. And I'm going to add that to this test tube here. Drops. And now what we'll do, if this solution over here had palladium in it, then we'd get a fluffy yellow precipitate going on because we just added some DMG to this. Now I'm going to show what that test would look like. I've added some palladium to this test tube here to some of the solution that was out of our beaker. Now I'm going to put some DMG in here. Watch what happens. I get a yellow precipitate forming in there from that palladium that I added to this. Very much, but it's definitely looking a lot different than this one. This one's staying clear, and this one's starting to cloud up because of the DMG, or the palladium that's interacting with the DMG, dimethylgloxine, and forming that fluffy yellow precipitate. Put this down here in this glass container. We'll just let this set for a minute. This is a copy of C.M. Hoke's book titled Refining Precious Metal Wastes. And on page 98, under Identifying Metals in Solution, she's got a test outlined here where we can check for nickel. She says rub a piece of nickel. A 5-cent piece will do, vigorously on the unglazed bottom of your spot plate so as to obtain a streak of metal particles. Dissolve the streak with a drop of nitric acid or aqua regia, and then add a drop of DMG. Nothing special will happen. Now, repeat this with this difference. After dissolving the nickel streak in acid, add a big drop of ammonia. Then add the DMG. If you used enough ammonia to kill the acid, you will see a very beautiful and characteristic color change. Now we're going to repeat the test as she's outlined it. I've got a Buffalo nickel here from 1936. She says to use one of these, so we're going to try that. I'm going to rub a streak of the material on the back of the spot plate. Also, I have a pure nickel coin that I bought just for this purpose. And what we'll do is I'm going to use this also right next to the Buffalo nickel that we just rubbed on there. We're going to test both of these. This is a pure nickel coin here. Okay, now she says to use a drop of nitric or some aqua regia. I'm going to use 14K gold testing solution here. We're going to apply a drop to each one of these. You see they begin to react there. The nickel piece that we used immediately disappeared. The nickel bullion is still kind of in place there. Okay, the next step was to add some DMG to both of these pieces of nickel that I've rubbed off on the back of the spot plate there. And as you can see, like the book said, no reaction. Okay, now I'm going to repeat the test. But this time, we'll add the ammonia. That's the 5-cent piece that she recommends using. Here's the piece of nickel bullion that I bought. I bought this on eBay, by the way. It's just a nickel bullion coin. Now what we'll do is add a little bit of this 14K gold testing solution. This is dilute aqua regia. I add a drop to each one. This time, before we add the DMG, we're going to add some ammonia here to neutralize the acid. In both of these tests, you see a little bit of cloud of ammonia coming off of there. And now we're going to add the DMG here. The ammonia has neutralized that acid. You can see we got a little bit of a pink tint to our nickel bullion side over here, but nothing from the nickel coin. Test one more time with our nickel bullion here. I didn't really get a good result there. Nice pink color like I wanted. So I'm scraping some nickel bullion here. I'm going to add some 14K test solution, which is dilute aqua regia. Okay, we're going to add the ammonia. This, just one drop. Boom. DMG to it. We get nothing. Just beautiful, man. Ammonia, so add more ammonia here. Oh yeah, there you go. You can see it's turning pink now. Let's see if this one does the same thing. Yep, there it goes. I just hadn't added enough ammonia to these. So when I added the extra ammonia and got rid of the excess nitric, we get this nice pink color, indicating we have nickel in solution. Okay, we're going to use these results to test a drop of this solution out of our beaker here. Put it right down here on our plate. And now what we'll do is add some ammonia to it to neutralize the excess nitric acid, or excess acid period. Oh, look at that. It turns dark blue. Okay, I know from previous experience that ammonia will indicate copper in solution by turning blue like that. So this test tells me what we've got in our beaker here is copper in solution. Add a little bit more ammonia to this nickel test here. That thing looks like it's turning blue. This nickel, this 5-cent piece here, does not look like to me it contains any nickel at all. Add some ammonia to these tests here and see what happens. Get a little bit of a pink indication here after I added that ammonia. And what that means is, in order to get DMG to produce this pink color and indicate nickel in solution, you must add the ammonia first to rid the solution of excess acid, and then add the DMG and you'll get this bright pink color. Based on this result right here, I think our solution in our beaker is just copper. If there's any nickel in there, and based on this test, there's no palladium in solution. This is our palladium that we added from our standard test solution to some of the green liquid, and you can see the precipitate that's formed in there. This is the solution out of our beaker. We added DMG to this, and there's nothing. It's crystal clear. So I'm going to conclude, based on these tests, this is all copper in here. We can just pour this off into our waste and get our silver now. All right, I wanted to demonstrate here sensitivity of this ammonia test for copper. I've got two identical beakers here. I'm going to put some distilled water in each one. Now what we'll do is I'm going to reach in our beaker here and get some of our test, or our solution out of this beaker. I'm going to add some drops to this one right here. 1, 2, 3, 4, 5 drops. What we'll do now, I'm going to add some ammonia to each one of these. I'm going to add it to the water first by itself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 drops of ammonia to the water. You can see there's no reaction. And then I'm going to add 10 drops of ammonia beaker that has the solution out of the silver jar here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see there's a color difference. This turns very blue. I'll tell us we got copper in solution. This one stays clear. We got no copper in solution. Test solutions, I'm just going to carefully empty all this into my waste treatment bucket. we don't have any precious metals in this solution. I'm going to take the piece of copper out of here. I'm going to add it to this beaker that I have over here. Get out of the way. And now what we'll do is we'll dump this copper solution in my stockpot down here. Here, distilled water, and rinse the silver out a little bit, and we'll add these rinses once it settles to the waste container down below. Alright, I've given it a couple rinses here with some hot water. I'm going to get this into a funnel now, and we're going to get it melted into a puck, so we can get a yield and see what kind of metal we're going to get out of this jeweler's waste. I just wanted to point out that the liquid up here in the filter still looks green, and then as it passes through the filter, comes down into this flask, it looks blue. That's something that I'm not familiar with, although I do know that copper in solution appears blue. So just another aspect of the jeweler's waste that this material is from, doing some strange things. Adding some more hot water to the silver in the filter here. Hopefully we'll be able to get a little bit more of the copper rinsed out of it. I'm going to put the silver in this melt dish now. And we're going to get it over on the melt table. Melt this up into a little button. Let's see what kind of yield we're going to get out of this from the jeweler's bobbing compound. I think this came out of. I can't remember. It's been so long ago since I've done the jeweler's waste that I cannot remember where this stuff came from. This footage is speeded up 8 times normal speed. You can see back there I added a second MAPP gas torch because that blob of silver in that filter paper is real damp. Well, in fact, it's sopping wet almost. Here I'm going to come in with the oxyacetylene torch to try to speed things up. I had to do this quickly because my oxygen bottle was running low. Also, I plan to get a new visor there to get all those scuff marks removed from this footage when we use the tinted visor. Here I'm going to slow the footage down to show you the silver kind of popped, and I think that was from the moisture. Boom, right there. that built up inside that that glob of silver there, and it kind of exploded on me. So I was wondering if that was ever going to happen. I knew it was a possibility. Here I'm going to sprinkle a little borax on the metal as it freezes. And then you'll see I've got to get it out of there quickly. Otherwise it'll adhere to that dish. You can see I'm prying pretty good with that pair of tweezers. But I eventually get it up and out of there. So you got to get that stuff out of there while it's still kind of almost semi-molten, so it doesn't adhere to the bottom of that melt dish. That blue color on there is an indication of copper contamination. Here's our button of silver here. We take it in, and we're going to put it in some water on the stove here. I'm going to add a little bit of sulfuric acid like we did before to dissolve off that little bit of flux that's on there. Okay, the piece of silver is all cleaned up. Turn this off. Gonna get this rinsed out right quick now. And again, the bottom looks like the moon. Now what we'll do is get this dried off. Take it over here on the scale. And we're going to take and get a weight on this thing. $27.7 grams. Not even 1 troy ounce of silver out of the jeweler's waste. Here's our little piece of silver from the jeweler's waste. And like before, what we're going to do is stamp SRI tips on it, and we'll try to sell this on my eBay store. Well, it didn't stamp very well on the first try, so I tried to go over the top of it to get it straightened out, and I ended up making a double strike on there. That's okay, you can still read it. It says SRI tips there. It's an error bar. 27.7 grams. That'll do it for this portion of the video here. We got a yield on that silver out of the jeweler's waste. We got 27.7 grams of silver here, about probably 98%, 99% pure. It's going to be contaminated with copper, but that's okay. I'm going to sell it just like it is. Back of it looks like the moon, like the other piece, which is pretty cool. And I stamped SRI tips on the front of it, but I made an error and made a double strike there. That's okay. We'll put this up for bids on my eBay store. Plus, I'll add a little bit of silver crystal and put that up for sale on the eBay store. And that's going to do it. Thanks for watching.